Hello. So in the earlier video that we saw, we were doing the calculation for AHP. Uh, Now what we want to find out is that the comparison that we've done, the pairwise comparison, is that consistent or not? So let's say if we have this example, we have in this case four features: so market, income, infrastructure, or transport. And we saw that the AHP calculation is pretty straightforward. You basically have to sum up uh, all the numbers in each column, and then divide each cell within the column from the sum, and then we take an average of all the fractions, and we get a preference vector. So in this case, we've done the calculation, and we have the preference vector. So we see that um, market has 19% preference, and so on and so forth. What we now want to find out is whether the pairwise comparison that we did, was that consistent or not. And by that what I mean is, so let's take an example of consistency. Let's suppose we were comparing three items. So in this case, we're comparing A versus B, and we find that A has a strong preference to B. So we would say A has a very strong preference could be, let's say, a 9 or a 7. So let's assume that it was a 9. Now if you look at the next statement, it says A is moderately preferred to C. So that would be something like, so we have A is preferred to C, but it's moderate. So we could assume that 3 would be the preference. And now we are looking at the third preference, and the third preference is C. Now, looking at these two, you can see that if A is very strongly preferred to B and A is slightly preferred to C, then C should be, C should be highly preferred as compared to B, right? But what we see here is C is equally preferred to B. So here we've done C is equal to B. So this is an inconsistency. Now this is only three. When you have three pairs, it's very easy to look at this. But remember, when you have four, then you would have, with four features, you would have 6 possible comparisons. And so as the number of features increases and the number of pairs increase, the chance of making a mistake in these comparison goes up. And what we want to do is we want to have a mathematical way of finding out if this kind of a mistake has been made. So to do that, we have something which is called a consistency index. Okay, so how does that work? So what we do is we take the original scoring that we had. So we have this original scoring over here. We have the preference vectors for market, income, infrastructure, and transport. And we're going to compute the consistency index. So we start by taking the preference vector from market and then multiplying all the cells within the market column with this number. We would take the next one, which is income, and multiply all the cells within the income column by the preference for income. So this would be 1 multiplied by 1.19, then same thing with 5, and you multiply with 1/3, multiply by 1/4. So this calculation is just repeated. So this was the first calculation. You repeat the same calculation for each one of these columns, and you add up these numbers. Once you add up these numbers, the next thing that you do is you take this number that you got here, and you divide this number by the preference score from the vector. So that gives you another number. So that gives you, for here, that would be 0.83 divided by 0.19, and that's 4.17. You repeat the same thing for all four, and once you repeated them, finally average the total. So you get an average score. So the average score that I have now is 4.15. Now you stick that into a formula, and the formula is, for CI is equal to the score that you get from here minus n divided by n minus 1. So n in this case was 4. So that would become 4.1564 minus 4, and you divide this by 4 minus 1. So that should give you the consistency index. So now you have the consistency. So here we've done the calculation, and you get the, so we have a score of 0.0521. Okay. Now if this was 0, then we would say that we have a perfect comparison. But you're unlikely to see a 0. You generally see some bit of variation. Next, what we want to do is to get a degree of consistency. To find the degree of consistency, we need one more number, and that's called the random index. The random index is something that you look up from a table, and what you look for is the n. So in our case, n is 4 because we had 4 features. So the random index will be 0.90. So the degree of consistency now is simply you take the CI, which we calculated already, which is 0.521. You divide that by the 0.90 that you looked up from the table, and we get a final score, which is 0.058. What you want to check for is if this number is less than 0.1, then you can say that your degree of consistency is okay, and you can go ahead and use this AHP calculation. However, if this is more than 0.1, then there is a inconsistency, and you should not use this performance factor in your calculations. So in this case, we can see that 0.05 is clearly less than 0.1. So we're happy with this pairwise comparison, and we can go ahead and use this preference factor.